Hey everyone, in the last video we built a social media multi-platform content generator where multiple agents work simultaneously in order to generate different content. But what if each question needs a specific agent? So let's imagine customer service where some questions go to returns, others go to order tracking, and others go to customer support. That's exactly what we are building today with the conditional pattern. So what is the conditional pattern? It's a pattern that intelligently routes requests to different specialized agents or workflows based on the context, request type, or specific criteria. Basically, instead of having a generalist agent, we use a classifier that directs each request to the appropriate expert. It's better to use it when we have multiple domains. For example, when your application handles several distinct types of requests, when we need specialized expertise. For example, in our customer service, we need an expert in returns, order tracking, and customer support. It helps us to optimize costs so we can use lighter models for simpler tasks, and it improves accuracy so we can have specialized agents deliver better results than generalists. The benefits of the conditional pattern: it increased precision, it's easy to scale so we can add new agents easily, it optimized cost so we can route to the appropriate model, for example, small or large model. It's also easy to maintain. Each agent can be modified independently. And finally, we can have better user experience. We can have faster and more relevant responses. Now let's have a look at the architecture. So basically we have customer query, which is the question. Next, we have a classifier who will classify this question, then send it to the router. So this router, based on the intent of the user, he will route the query to a specific agent. And then there is some processing. Then it produces the final response. As you can see, depending on the customer query, we will use a specific agent. For example, for where is my package, we will use the tracking agent. And for the website is not loading, we will use the technical support. Now let's have a look at Python implementation. So this is our requirement. In this case, we will be using LangGraph, LangChainGrok, and Python.env. So for the important libraries, as I said, we need LangGraph.graph. We will import state graph. Basically, this is the main class to build our workflow stateful graph. We also need the and in order to specify the and of our workflow. Next, we need to import type dict to define the structure of our state, and literal to define the only allowed values. We also need human message, which is a wrapper for user messages when calling the LLM. We also need JSON in order to parse the JSON response from the LLM. And as usual, so we will need chatbots in order to use the LLM, OS, and .env. So first we need to load .env, initialize our LLM. Next, we need to create customer service state. So this class will help us to keep the status in each node of our workflow. So we have these attributes. So we need the customer query classification in order to classify the question of the customer, order number if we have an order number, agent used. So this will help us to route the query to the specific agent, and finally the final response. Now let's define our classifier node. So this is what we will define here. First, we need the query. So we will get the query from the customer service state. Then we prepare our prompt. So we will tell the LLM to classify the customer query if it's a return, tracking, technical, or general. Next, we call our LLM. We will do some cleaning to clean our response, and then return the state by overwriting the classification and the order number. The next step is to prepare our routing. So we have this function, route query, takes as input the customer service state, and we need to return only one value from the literal. So we define a routes object, and this object can return a return agent, tracking agent, technical, or general agent. And finally, we will return the appropriate agent based on classification. Next step is to define our agents. I'm talking about this step here. So we have the returns agent. It also takes as an input the customer service state. So we will get the query, the order number. Next, we need to define the prompt of this returns agent. So we just say you are a returns specialist for an e-commerce company. So we will pass the query and the order number if we have it. We invoke the LLM and then return the state by overwriting the final response and the agent used. In this case, it's returns agent. Next, we will do the same thing for the tracking, technical, and general agent. As you can see here, the only thing that we changed for every agent is the prompt. For the tracking agent, we said you are a shipping specialist for an e-commerce company. For the technical agent, we said you are a technical support specialist. And for the general agent, we didn't specify the skills of this agent. Now let's build the graph. So we define a build graph function. So in this function, we create the workflow, which is the state graph, and we pass the customer service state as an input. The second step is to add all the nodes. So we will add classifier, return, tracking, technical, and general agents. The third step, so we set the entry point. In this case, it's the classifier. Then we will configure our conditional routing. So we'll use add conditional function. Inside, we will have our classifier and the route query. Inside, we will have all the agents in order to let our router decide which agent he will be using based on the customer question. In the step 5, we need to specify the end of our workflow. So we just need to add edge and specify the edge of our workflow. In this case, it's all the agents workflow. And finally, we compile our workflow. Now let's test our workflow. So this is our main. We will define test query object that contains 4 questions for each LLM. Next, we will call our function build graph in order to build our graph. And then we will loop over all the questions or queries. Inside our loop, we will create a state for each question and overwrite our customer query. Then we call our graph with the state and finally print the classification, order number, agent used, and the final response. Now let's test our conditional customer service workflow. As you can see, for the first query, I want to return order and the order number. The classification here is a return order number, and the agent used is a returns agent. This is the response. Same thing for the tracking agent, technical agent, and the general agent. So now let's have a look at N8N implementation. So basically, we'll have an input here. So this input will be sent to a classifier. Next, we will have our router. So the router, he will decide to send the question to a specific agent. So this is the list of our agents. And finally, we will produce a final response. Basically, we need a trigger and also an input field. So in this case, my question is, what are your hours? Next, we will send this question to our classifier. So this is the prompt that we will use for the classifier. Basically, it's the same prompt that we used in Python. The only thing here, we replace the query with the question that comes from the input field. Regarding the LLM, I'm using Llama 3, and I already showed you in the first video how to set up your Grok account. Next step is to call the classifier. So basically, the classifier takes as input the response from the LLM, then do some parsing and return the customer query, the classification from the LLM, and also the order number if we have an order number. In this case, we added the timestamp. At the end, we will return customer query, the classification, the order number, and the timestamp. The next step is to call our router. The router takes the response from the classifier, and then he will route the response based on the classification type. As you can see here in the router, we have different rules. If the classification is return, we will call returns agent. If it's tracking, we will call tracking agent, technical agent. And finally, if it's general, we will call the general agent. So based on this condition, we will output the customer query and also the classification and the agent that we will use. The next step now is to define each agent. So for example, for the return agent, so I took the query that comes from the router. So this is the question, the classification, if I have an order number. And here what I did, I just replaced the parameters in my prompt. So this is the input from the router for the query, and this is the order number. Same thing for the tracking agent. I'm just replacing the values in the prompt. For the technical agent, also the same thing. Just replace the values. The same thing for the general agent. So the final step now is to parse the response that comes from a specific agent. So this is a JavaScript function, takes the response from the agent and clean up the data in order to have a better output format. Now let's test our workflow. So first I will use this question. What are your store hours? Let's execute the workflow. As you can see here, it chose the general agent because we don't have any specification in the question. Now let's do another test. I will use this time tracking agent. Let's change the question. Let's run it again. As you can see, the router chose the tracking agent, and this is our response. I will be happy to help you with the tracking information for your order and so on. Let's do another test for the technical agent. As you can see, it works. This is the response. And let's try now the returns agent. Good. As you can see, it works. So let's see what's happened. This is the question. We have our classifier. The category is a return query. This is the parsing. So we have classification, order number, also timestamp. Also the router, he classified it to return order number, timestamp. And this is the final response. Thank you for reaching out to us about returning your order 12345. We're happy to help and so on.